Hello everyone, welcome back. Long time there was no video, I was on a break, and also I was working on a new functionality in Sparrow, new features, and today I'd like to show few things that I'm working on. I call this functionality experimental, and this is Sparrow logic. It's not based on any AI or LLM. What I'm doing, I'm adding additional pre-processing and optimization functionality in Sparrow to improve large table processing. So the idea is that often when you pass a large table, like a bank statement or some insurance information table into LLM, then you might get issue with one second. You may get issue with hallucinated values, and especially it could be problematic when tables have empty cells, and then Vision LLM may lose the context and it will start to populate some actual values for the empty cells, which is completely wrong, and all the data is corrupted at the end. So I'm trying to solve this with additional Sparrow functionality where I'm improving tables. I'm, for example, drawing grid for the table to provide more contextual information for Vision LLM for the data extraction, or I'm using plain OCR and I'm passing OCR data together with the image to help and improve Vision LLM output where it would map key value pairs together. So in this test, in this example, I'm running test script over here, and in this test script or experimental logic, which is not yet on the GitHub, I'm trying to draw columns and basically vertical and horizontal lines, and build the column grid for the table, which by default comes without the grid. And this, based on my testing, this helps to improve at the end Vision LLM output functionality. So let's run a test. I'm using for this test a simple table because it's like a public data. When I'm doing development work, I'm testing with client data, which is more complex, but I'm not able to share it with you on this video. So the test executed, and we can see that from the log there are in the first phase detecting if there are any existing vertical lines, like showing columns, right? And it says no valid lines detected, so let's use text density analysis. So my algorithm then works the same way like human brain would work. It tries to group entire table area into columns by checking like a logical text alignment, where like first column most logically will be second column and third column, and then it tries to draw vertical lines to identify the columns this way. Right, and then if you go here, we'll see it identifies different peaks and then tries to filter out false and false data out of entire array of data, and to make sure that we are not building just too many columns, just building as many columns as we should have. Right, then we see we are evaluating different in my algorithm running different methods or approaches how to identify columns, and then at the end I'm validating outputs from different approaches against each other and selecting the one which looks better and using it to produce the grid. Also in the same algorithm I'm building horizontal lines, but this is not yet complete. I'm working on this and hopefully I'll share how it works in future videos. Okay, and in this case detection confidence is around 60%, medium, which is based on my testing is quite good, because even at least having some context or improvement for original table image, it may greatly help in the next step for the Vision LLM data extraction. Right, so let's see the result. So here, and first of all, this is the original image. There are no columns. Right, there is some there are some horizontal lines in this case, but no columns. Okay, and this is the image, the same table after post-processing. Okay, so let me open again the original one and this one after post-processing. So we have identified very well vertical lines, this one missing here, this one, so some more tuning needs to be done for the algorithm, but overall it works quite well, and horizontal lines were also included based on existing lines. Right, and if in this table some of the cell values will be empty, like no value, then in case of table is large, then as I said before, Vision LLM would really struggle to correctly read the data. But when we are using this kind of grid, then results of the Vision LLM extraction with this kind of improved table improves by far, by a few times. And yeah, in the algorithm I'm using Vision functionality. I'm not using any AI here. Detecting the text density, and then based on minimum and maximum values, I'm constructing the let's say I'm detecting the location where most likely the vertical lines for the columns would be aligned, and also horizontal lines are being detected. And for the row detection, there is a second part of algorithm. It also detects horizontal density, and this is how horizontal lines are being constructed. This doesn't work yet with all the types of tables, so this is what I'm working on, and I'm adjusting algorithm and improving it. Right, so this is the thing that I was working lately. Hopefully you find Sparrow useful, this online instance. The current functionality I'm describing now, it's not yet part of the production instance on sparrow.katanaml.io, but once this work will be done, it will be there available for you to test. Also, this is experimental code. It will not be part of the GitHub in the near future. It will be part of the online instance, but not yet for the GitHub. Later in future it will be on the GitHub as well. For now I'm using it in experimental mode and testing locally with my sample documents and with client documents. So thanks for watching and see you next time. Bye.